So, it looks like there's about 100% more people here than I was expecting. There's Troy Hunt on in the other room. Anyway, stay here now. You're here, you're not allowed to leave. We're going to lock the door. So, my name's Andy Davies. I work for a smallish financial company in Finland. And while we make a service that my team cares a lot about, I don't mind the product. It doesn't fascinate me. I don't dislike it. What I like doing is making other developers' lives easier. And 12-factor microservices is a way that I can help them do that, because they don't have to think so much about how do logs get into the right place, where's the monitoring, what library should have I installed, I've forgotten to add this bit of runtime configuration that only shows up in production. So the 12-factor services help standardize the way you develop applications. Doesn't have to be microservices, but it's obviously what we're going to be talking about. And it aims to make it more consistent, portable, like Windows, Linux, that kind of thing, scalable and declarative. There are some trade-offs, and I don't agree with all of the points in the 12-factor, and I will point out which ones I don't like. Yeah, and they were originally written by Heroku for deploying applications to their platform as a service. But they've opened them to everyone, and good guidelines in general. That being said, the first one is the Codebase. You should have one Codebase tracked in revision control and many deploys. Now, this means a one-to-one mapping with a repository to an application. Lets you answer questions fairly quickly as well. Where's the web UI? Well, it's in the repository called web UI, rather than in a folder called documentation in the utilities repository, which is on a different account for reasons. So you're going to try and remove some friction by naming things and putting them in the right place. But a lot of time, people want to put multiple applications in the same repository. If you've got multiple applications in the same repository, each application itself could be a 12-factor application, but what you've got in your repository is a system, not an application. The way this really comes into effect is a lot of people online recently have been going on about these three companies who use monorepos, and they're very big and successful companies, but they're using a monorepo, so we should too, which is a terrible way of doing things anyway. But you're not Microsoft scale or Google scale, at a guess. I mean, we certainly aren't. Also, at least two of these companies have written file systems to get around the fact they have a monorepo. Now, I don't know about you, but I really don't want to justify to a project manager that I need to write a file system, because not only would that take a long time, I would fail, and I could be delivering business value instead. So if you're going to be writing a file system, perhaps you're solving the wrong problem, unless you've got a very good reason, like the Windows Codebase, for instance. The counterpoint to this is that companies which are doing microservices and who write about it don't use monorepos, for the most part. And Riot Games in particular, they write a lot about how they do their engineering and how they do their deployments. So the engineering blog is a fascinating read. I highly recommend it. But I think we need a more concrete example rather than me just wittering about repositories. So if we have the stereotypical complicated application, it has some kind of queue, we're going to read things off the queue, transform them, have some kind of HTTP API to read them out of the data store, and some kind of background process which will be doing, well, probably cleaning things up for GDPR compliance. Now, if you're doing this like in 12-factor and reading it very much as one application per repository, you're going to end up with 3 repositories, a consumer, an API, and a background. But the problem with this is these 3 things are going to share some stuff. I mean, they're all going to be writing to the same database. So there's probably some kind of models that they need to, well, not necessarily need to, but it would be useful to share between them. What about acceptance testing? If you want to write a test that says, given an event, it should get consumed correctly, then it should appear on the API and eventually get scrubbed up by the background process. Where do you put those? And also, what about any infrastructure code that you've got? So if you're using Terraform to spin up the actual database cluster, that needs to go somewhere as well. So you could have a fourth repository of like stuff, which then becomes a dumping ground, and that doesn't feel right. So what I do in this case is just put it all in one repository. So I've got a mini mono repo, rather than I have many mono repos. It's fine. So we have a source directory which has got our 3 main projects in it. We've also gained a tests directory and a common directory. There's also a directory for infrastructure stuff, which has got Terraform scripts in this case. And then we've got some build, publish, and a solution file in the root. We've now got somewhere to stick all of our shared code dependencies, if we've got some, and places to put our acceptance tests. We've also contained what makes the services boundary into one repository, because this is one piece of functionality, so it's in one place. Just because there's several processes that make up this functionality doesn't mean that they should be separate repositories. It is a trade-off with all these different things, as it always is. But we'll build on this as we go through. So the next factor is dependencies. You should explicitly declare and isolate them. This one's nice and easy. Basically means don't use the GAC, but no one wants to anyway. Use NuGet. You're making your dependencies declarative. You just say, I want this version of this package, and it arrives. You shouldn't be relying on those packages to be there on the target machine. So it should be part of your build process to pull the packages in at one time and then deploy that one unit. This means not, say, copying your Node.js application up to a server and then just running npm install and npm run and hoping it works, which it won't. But this goes further than NuGet packages. It also means you shouldn't be using system utilities. This is a pretty terrible example, but if you wanted to call out to dig and find some service by querying DNS, you shouldn't just be calling dig, because how do you know that's available on the system that your application has been deployed to? And if you're deploying to Linux, it's probably there. If you're deploying to Windows, it almost certainly isn't. I mean, it is on my laptop, but I'm a developer, not a container host. You also end up with the problem of if you are deploying to, say, an Alpine Linux container, and that's got one version of dig on it, but then someone else deploys it into an Ubuntu-based container that's got a different version of dig, which has a slightly different output, and now you've got to try and parse 2 outputs, and you don't know which one's which. The way you get around this is just to package up the utility with your application. Deploy a copy of dig with your application if you need it. Or try not to use something like this. There's bound to be a NuGet library for accessing DNS instead. But by isolating that dig or curl or whatever other dependencies you've got to specific known versions, you now don't have to code around the fact of your outputs might be different or it doesn't even exist. It's only a little thing. I mean, we don't often need to call out to system utilities, but be careful if you have to. Now, this is where I find it starts to get more interesting, partially because I disagree with a lot of this. So the third 12 factor says that your configuration should be stored in the environment, and only in the environment. But if we're doing .NET applications, we're used to web config files or app configs or the .NET Core uses a JSON file. You shouldn't be doing that according to these. You need to read from environment variables. Now this is very easy in .NET Core. If you're making an ASP.NET Core application, you've already got the first 2 packages installed. You just add the third package and then add this line. Where's my pointer? There we go. I'm not very good at this. Add this line which just says read from the environment variables with a prefix. Also note that I'm using the configure services method to build a strongly typed configuration object and not using the configure app configuration method. This is because I do not like the iConfiguration interface flowing around through code, because you just access properties by string names through that, and now you've got binding issues happening later. You try and access a property by string name, it may or may not be there. Not very good. I'd rather get the binding error at startup. This if you've got a property that's typed as a URL and you try and load something that's not a URL into it, I'd rather the application fail to start than suddenly not work later when a bit of functionality is called. And our actual configuration, in this case, just has a database connection string, database name, rabbit MQ host, and a username and password. Now, can anyone see any problems with the configuration that's come from the environment with this? And the clue is, don't store sensitive data in your environment. Just don't do it. API keys, connection strings, usernames and passwords, these should not be in environment variables. Now, when Heroku were doing the 12-factor, I think when you read an environment variable from a Heroku application, you're probably accessing some actual key value store that's doing secure storage. At a guess, this is all speculation because I don't know for sure, rather than real environment variables. Because otherwise, depending on how they host your application, you might end up reading someone else's environment variables, which would probably not be good. There's also, if you have all the data in environment variables, it kind of implies that they're not being centrally managed. And if you need to suddenly revoke, say, an API key because it's been leaked, you now have to find all the containers that have got it set as an environment variable somewhere and change it and restart them. So things like connection strings should be stored in console. If you've not heard of console, it's a service discovery tool by HashiCorp. It does a lot of other things as well, such as service health checking, and also has a key value store. But it's not secure storage. Luckily, HashiCorp make another tool, and I think quite a lot of the talks at NDC this year have mentioned Vault and console. Vault does secure credential storage and builds on top of console in that you can store the actual values in encrypted format in console, but you access them through Vault, which lets us do interesting things like only generating a username and password for the database when you need one. So rather than having a fixed connection string, Vault has a connection to the database that lets it create new users, and when your application needs to connect, it asks Vault. Vault generates a username and password. You then connect to the database, do your stuff, and then that expires after a short amount of time. To actually read your configuration out of these, we had one NuGet package, which annoyingly has the console name at the front. I wanted to call it Microsoft extensions.configuration.console because everything else is, but Microsoft is a protected prefix on NuGet, so I couldn't. But again, all you need to do is add one line, add console and a prefix. And now your application will try and populate from both the environment variables and from console. And then when you actually want a database connection string, then you go to Vault and ask for it. You could read it on startup, but you start getting into the interesting thing of Vault is hosted somewhere, so you need the connection string to Vault, which means you need to read from console to find out where Vault is, but you can't do both of those in the startup, because when the read from Vault, or if you did an add Vault in this, it would need to know where console was, but it can't access the console settings until the object's there. So yeah, it's a bit awkward, but workable. Talking of connection strings, the next point is that all your backing services should be treated as attached resources. Now, this made no sense to me when I read it the first time. What's an attached resource? A backing service, I understand. That's another service I call, but what it means is anything that goes over a network boundary should be treated the same. So if we have an example of my call application, it's in a container. It's using console, which is technically over a network boundary, but it's talking to an instance on localhost, so kind of doesn't count. And then it has connection strings to Kafka, Postgres, and Twilio. Now, Kafka and Postgres are something that's going to be run by us, probably. It could be in a Docker container somewhere, could be on some EC2 instances, or it could be in Amazon's RDS service. But it's only a connection string. We don't know where it is, we just know that we have a connection string. Now, if we wanted to move Postgres, We could move it to, and how you actually go about moving it is definitely the subject for another talk. But let's say you spin up another instance of Postgres because you've noticed that your database is beginning to die for storage reasons. So you spin up a new instance, and you want to change where this application is looking for its Postgres instance. And all you need to do is change a configuration string and restart the service. You don't have to log in and to the server and do anything. You don't have to change the application and redeploy it. So it should be a runtime configuration to change your database. This doesn't mean you can change your database from Postgres to SQLite by just changing the connection string. And no matter what anyone tells you about ORMs, you can't do that. It doesn't work. There's completely different guarantees on safety and transactions, and yeah. But it also affects, like, Twilio. We don't control Twilio. I have no idea where it is. It's just a URL at this point. But I could replace it with something that looked like Twilio. So for local testing, I could have one of those recording and replay HTTP frameworks. So, if you're testing locally, you probably don't want to be sending real text messages to people. But again, it comes down to just a connection string. So we're treating these things as all the same. A backing service can also be another one of your services. So in this case, I've just got 3 third-party services, but it could be another one of your applications. To actually deploy and run your applications, we need to have completely separate build and run stages. This goes back a bit to what I was saying earlier about not just copying your Git repository of your your node application onto a server and running npm install, because, well, you only have to go onto their bug tracker to see how much fun that causes. So, no modifying things in production, and you shouldn't need to recompile your application to deploy it to a new environment. So if we have our master branch, and because we're cool young developers, we're doing trunk-based development, which doesn't mean no branches, it just means shorter branches. So we create our feature branch, we do a couple of commits to it, and we open a pull request. The pull request automatically triggers a build, which is going to run the build script, which is contained within the repository. So it shouldn't matter what your build server is, as long as it can execute a bash script. In my case, the bash script looks something like this. It's a bit trimmed down, but... So here we grab the mode off the command line, so it'll default to debug if you don't fill anything in. So the build machine obviously builds it in release mode. We find the name of the solution file, build the thing, find all the test projects, run all the tests. Then we publish to a known location, and you'll see I'm publishing in Linux 64 mode as well. And then we find all Docker files in the repository and run a subscript which deals with Docker. So we're going to generate a Docker container for each one. You could also do things like baking AMIs or generating NuGets if you're deploying with, say, Octopus. Assuming your pull request is accepted and you merge it to master, the master build will then run. This runs the exact same build script, but then follows it on by running the release script. Or publish, it really should be called, but... The publish script just finds all the Docker files again, and this time runs a Docker publish, which does something similar to this. Find the latest version of the Docker file, tag it with the repository you want to push it to, and then push it to that repository. I do not understand why I need to tag a Docker file with the repository it's going to go to if I'm then going to write Docker push and the name of the repository. Makes no sense to me, but that's how it works. So my publish step is completely separate. Developers can run the build step on their local machine and get the same output as the build machine will get. If they run the publish, it'll fail because they don't have the API key, which is obviously taken through Vault. We push our artifacts up to our container repository, and at this point, something happens to make it go into, say, your test environment. What that something is, you could probably fill a conference with. There are so many different ways to deploy in different ways. I tried to come up with a generic way of saying then you run this command and everything's happy. But depending on what your cloud is, how you're running your containers, or if you're not using containers, there's just too many options. In my case, I tend to use Terraform and just update a load balancer to say, use this new AMI ID, because I tend to use AMIs rather than Docker containers. And then I just kill containers at random until the new one is up and running. But then when we want to push it into new environments, we effectively run that same piece of deployment script again, but giving the new environment name. So we're not regenerating the containers or anything, we're just changing the tag against them to say, this is now also used in QA. This is now also used in prod. Because we're using console and Vault to get our credentials of things, we have no configuration to change between the environments. Everything that's environment specific is stored in the environments, be that in environment variables, console, or Vault. So our containers are essentially very dumb. On a local machine, you can run a local instance of console which just points at, say, a Dockerized version of Postgres. And you don't have to change any kind of configuration then. So this is just another thing that's trying to remove a little bit of friction from a developer's life. They can run the application locally, then it will probably work in the other environments. Now going back to our repository structure from earlier, we should execute the app as one or more stateless processes. This is why I was able to get away with putting 3 separate services in one repository, because they are separate stateless processes. Now what it means by stateless is that you shouldn't be relying on requests that have previously happened to do the current request. Now, when you need to store something, you're allowed to push it to a further backing service, which can do statefulness. Eventually, you'll get down to a database or something that actually is stateful, but most of your services should be stateless. You are allowed to use memory or disk, but only for the duration of one operation. So if you're handling many API requests, you can't write a file to disk in one API request and then expect it to be there on the next API request, because you might have multiple copies of the process, so it's not on the same machine, so the file isn't there. That's where you should go to a backing service. Excuse me. The interesting point comes with this is when you want to think about caching, because we all end up putting caches in various places, but if you can't reuse memory or disk between requests, how do you even cache something? It's not there. I mean, if you're running many copies of container, you're probably going to have low cache hit rates anyway, because the likelihood of a request hitting the same container is quite low. I do, however, do some caching, but it's always really small. Something that will just improve speed slightly. Doesn't have to be there. If I get a cache hit, great. If I don't, doesn't matter. If you're doing something like consuming off a Kafka topic, maybe your topic could be, what's the word? The topic segments. I think that's the wrong word, but I can't think what it is at the moment. You could have each consumer subscribe to a segment in a certain, with the segment set up so that you would kind of improve the likelihood of cache hits. So it is possible, but you tend to want to push caching in front of you further away. So you could have a caching service, but it shouldn't be one of yours because by definition it's not 12-factor. So yeah, caching is a weird one. Much more interesting is port binding. Now, exposing services via port binding means that you should be hosting the HTTP server. You shouldn't be using IIS or anything else. And this is not just for HTTP, but it is the most common use case. Could also be XMPP or Kafka. But you shouldn't be using IIS. Now, before .NET Core, this was a pain, because you were generally hosted by IIS, and IIS gives you loads of fun things. XML configuration, complexity, killing app pools at random, which is my favorite, and SSL termination. Now, one of these 4 things is something that I like. I don't want to have to deal with SSL termination. However, if I can get rid of XML complexity and killing app pools, great. I did try once to do SSL myself with an application that was using ON in self-hosting. And that was a pain, nearly as much pain as configuring IIS. Because you have to use NetSH and bind the certificate to the application in the right location and to the port, and then when you deploy a new version, something's locked, and everything fails. But if I'd known about a certain feature of IIS, we could have just had it configured as a reverse proxy. Now, reverse proxying in IIS is possible, but if you Google for it, you will have lots of pages which show you lots of screenshots of where to click, and that annoys me because I want a script to do it. I don't want to click anything. But if you do enough searching, you'll eventually come across a guide on how to do it using Nginx. Most interestingly, the guide is written by Microsoft. And it says, you can configure a web server to do SSL termination for you, such as IIS, Apache, or Nginx. The guide will be in Nginx because that's the easiest. So I like the fact they're throwing shade at IIS, because, yeah. So to do this with Nginx is really simple. I've included most of the important bits on this. Your application listens to HTTP on a fairly high support number. Whatever you want. .NET Core defaults to 5,000. Nginx, and also your application only lists on localhost. You can't listen on a public interface. Nginx in your container listens on port 443 on the public interface, and effectively will just forward all the requests after doing SSL termination to your application. So we modify our startup to 4 support number. You don't have to. Like I said, it defaults to 5,000, so you could just assume. One thing to note is if you're doing service discovery, don't publish this URL into console, because you'll be scratching your head for hours trying to work out why this works on your machine but doesn't work when you promote it into a production environment, because you're publishing, my service is available at localhost 1234, which is a different localhost to the thing trying to access it. So yeah, don't publish this URL. You want to publish this URL at the top. So this is an Nginx configuration file. There is a lot more that I've chopped out of this. The URL at the bottom, which I will show later on the end slide, has the full guide that Microsoft have written. Essentially, this sets up listening on 443 on all interfaces. We've named the server example.com because that's a great server. And we have a certificate set up so that we can do SSL termination. The important part is the last 3 lines, or last 4 lines technically. Anything under the location / pass it through to localhost port 1234. And that's it. Your application will work and be serving under HTTPS. Now you can bake this into your Docker container. So when you're setting up Docker containers, I tend to have like the base container, and then we have a services one, which has got an instance of console configured on it, and it's got Nginx set up ready to work. So all you have to do is deploy your application and start listening on 1234. The only problem with this is if your application needs to do anything with authorization. Because the .NET framework is reasonably clever in this, in that if it detects that you're trying to do secure things and you're operating on HTTP, not HTTPS, it won't let you do it. And of course, if you're being hosted, would you stop that? If you're doing this, as far as your application can tell, it's on HTTP, not HTTPS. So every time you try and authenticate, things will fail, because it's like you're not running on a secure schema. We're not going to let you send passwords, which is good. So we can get around this with the Microsoft ASP.NET Core HTTP overrides package. You install this and add. All right, this is going. We add these 3 lines. Nginx will add, as will others, proxy headers. So it'll tell you what the scheme was that the request came in, what the original IP address was, and what the original host was as well. By adding this middleware, when a request comes in with these headers, the middleware will rewrite the HTTP context object to have the same scheme as this header and the host and the remote IP address. So your application now thinks it's running on HTTPS. So your authentication works again. And I'm sure I would have eventually managed to solve this myself, but probably not very quickly. And there's a Microsoft package to do it, because they realized that if they're trying to promote you into using reverse proxies, you should probably also make authentication work. The other piece of guidance for this middleware is it should be one of the very first ones you add, just after you're debugging one and before the authentication call. If you add it after the authentication call, when you're debugging, it'll look like it should work, but it won't, which is great fun. Now, for actual deployment of our applications, I tend to have Heroku running in front. I assume that's how you pronounce Heroku. I don't know. I've only recently started calling Nginx. I always call it Nginx, because, yeah, but I don't know. Apparently I'm wrong. So anyway, I have Heroku running in front. This is publicly facing, and that's sending all of my requests to my application. This lets me do another fun thing, which is to have different SSL certificates for internal and external. So the public-facing has one SSL certificate, Heroku does a termination, and then starts a new SSL connection to everything inside my network. I can't remember why this is a good thing, but I've been told it is a good thing to do, so I do it. And it's easy to set up. But as we're software developers, we tend to like doing this kind of thing, and we're writing applications, and we write a blog post about our new JavaScript front-end framework. And we post our blog post to Hacker News and to Reddit, and suddenly the whole internet arrives. Because for 5 minutes, we're the latest JavaScript framework. In 5 minutes' time, it won't matter, because there'll be another 6. But we need to deal with this spike of traffic. And our one little application is probably not going to manage it. Heroku will be fine with it. It's designed to do this. But our little application, probably not so much, especially if it's in a little Docker container. So how do you handle concurrency? The 12 factor says that you should scale out via the process model. This essentially means when a big amount of work comes in, run more. Which is great, but you have to be careful because a 12-factor application should be share nothing. So you shouldn't be sharing any kind of disks or state or anything, memory or CPUs. So usually this would be in Kubernetes or many Amazon EC2 instances, so hopefully it's distributed load everywhere. But if you have a load balancer and it scales up lots of these applications, this is only the first tier of applications. You've probably got some backing services. I hope those scale up as well, because otherwise you've got one backing service which is suddenly being hit by 40 of your service, and now you're denial of servicing yourself. So yeah, scale out via the process model, but be careful of downstream effects, because they also need to scale. Or put queues in place, lots of queues. But when you're scaling applications, you have to be careful about the next factor as well, which is disposability. You should be maximizing robustness with fast startup and graceful shutdown. In other words, the quicker you can handle and stop handling requests, the better. If we have this little graph, with orange being our little spike from Reddit, and it takes a long time for our containers to start up, by the time the spike has finished and has started to tail off, we've only just started up our containers. So we can't deal with the load very quickly. Also, if it takes a long time for the container to shut down, then we're effectively paying money for wasted resource because you are now consuming more CPU, so at some point it's costing you. So you should shut down quicker. Also, if you're starting up and shutting down faster, it means your service has less downtime if you're needing to change a configuration file, or a configuration value, which involves restarting the service. If it takes 10 minutes to restart, then you've got a time when you're at least one service down. And if another one dies, then maybe you haven't got any running. And then if it takes a long time to start up, well, you're still not serving requests. It also states the sudden shutdown should not cause data loss. Now, there was an interesting story I read about this a couple of years ago, which means I cannot find the link to it or the blog post, and I might have imagined it. I hope I didn't. But it was a company that had a desktop application, and this thing had a horrible memory error which would cause it to die randomly a lot. And it really annoyed the users because obviously the application shut down, but they lost all the progress of whatever it was they were doing. Now, what they did is they went in and wrote a lot of things to disk so that as they were doing the operation, if the application crashed, it could just resume from where it left off. And this is great. I mean, it solved the problem in a way that was easier for them to manage. But an interesting side effect of this was that the graceful shutdown for this application took quite a long time. And after a while, someone realized, why are we even bothering to do a graceful shutdown? If we can resume from an application crash with no data loss, let's not gracefully shut down. Let's just terminate the application. It'll just resume. It'll be fine. So they removed their graceful shutdown and just went, yeah, terminate now. Oh, by the way, status code was successful. It's a good exit. And they sped their application up. Now, I'm not saying you should be trying to do this. I mean, fix the memory issue. But graceful shutdowns, in the case of a microservice, should mean stop handling new requests, finish the existing ones, then switch off. They shouldn't cause data loss because, hopefully each request is fairly small. But yeah, if you can make things resume, but you can't because you're not allowed to write to disk. Yeah. Our next point on the 12-factor is development and productivity? Development and production parity. All your environments should be the same as possible. Now, the first part of this is the obvious one. It's infrastructure. Each environment should be roughly the same. Maybe your production environment has a lot more resource than your development environment, but your test environment should probably have at least some things. So if you're running 10 instances of your application in production behind a load balancer, and you're only running one instance in test with no load balancer, that's not the same. One instance with a load balancer that just sends everything, that's better. So you should try and keep things very much similar so you know how things are going to work, because a load balancer not being there might break in between the environments, especially if you've got differing certificates. To manage this, we go on to our next HashiCorp tool. Now, I'd like to point out I'm not paid by HashiCorp to advertise their products. I just like them a lot. But if they wish to pay me. So Terraform is for declarative infrastructure. As an example, we write something like this. It's a JSON-ish format. This here says that we want an Amazon database instance. Locally, like within the file, it's going to be known as the storage one, because I'm great at naming things. And it's going to be Postgres, because that's the best database. And we're going to use a T2 micro, because I'm stingy and don't want to pay for things. The username and password in this case are going to be pulled off the command line, which is going to come from Vault, because I don't want usernames and passwords anywhere. Now, if we run this with no infrastructure in place, this will cause a database to be created. If we run it with the database in place already, nothing will happen. If we run it and someone has logged into the AWS console and tweaked the settings because they wanted to have more disk space for whatever reason, this will undo that change, as it should do. Don't tweak settings in the console. Change the config file and redeploy. Because now, when we run this in every environment, we end up with exactly the same in each environment. We can tweak certain things, such as number of CPUs available, amount of storage, on a per environment basis. Now, I mentioned earlier about trying to deploy applications. And this is one way of deploying a Docker container. So this would be our build server running this script. The first block is a resource. So this, no, I've gotten the wrong word there. It should be a data source. So this should look up our existing ECS cluster, because this will be managed by some other script. So we'll have Terraform scripts in our repository which just deal with what is needed by this application. But there'll be other scripts and things running to set up VPCs and security groups on a higher level, stuff that our application doesn't care about as such, but needs to function. So in this case, we're going to look up a cluster. It's going to be called main, because good naming again. And we're going to create a task definition. It's using Amazon's Fargate thing, which means that I don't have to think about EC2 hosts, which makes me happier, because that's less infrastructure to think about. And each one of these containers is going to be given one CPU and 256 meg of memory. And it's going to be running one container, which is going to come from the app image on the command line. So this is the same ID that our build server would have passed through to publish the container. So we can now use that same version. Finally, we're going to update the ECS service to use that task definition and push it into the load balancer, which is going to be listening or passing things through to 443. This is missing a lot of things to make it work, by the way. I wouldn't recommend just copying this off the slide. Again, there are some guides that have a lot more information on how to do this. I think I have a link to it at the end. If not, I will try and find it and tweet it out later. So our environment, which is Terraform managed, looks like this. This is our production version. So we've had a Terraform script which probably set up Postgres for this. Kafka is probably not our application concern, and it will have been looked up from somewhere. Twilio is not something we can deploy, so again, our script would not have anything to do with it. But when you're developing locally, you tend to not use quite the same things as production. So when we say development and production parity, we mean if I'm using using Postgres in production, I should be using Postgres when I develop locally. Should not be doing this. Because again, as I said, your ORM is not going to help with this. It might work, maybe, a bit, but it's not worth trying. I did have a previous slide that had Kafka switched out for RabbitMQ, because they're both kind of to do with queues, but they're very not the same. So our environments, not only should they be the same, but they should be very much the same classes, so you hit the problems of, say, the GUID type not quite matching up. Like SQLite, I don't think has a GUID type. I think it's just a string internally, and you have to map it into GUID. And how do you know if it's using big endian or little endian to store it? So hopefully it's the same style as Postgres is, but it might not be, so maybe your application will or won't work. Make sure they're the same. But it's not only that the application and its resources are the same in each environment, it's that it should actually be the same in all environments very quickly. Once you've pushed a branch into test, oops, yeah, don't touch that. Once you've pushed a branch into test, it should only take a few minutes to a couple of hours to get your artifact into production. Now, this is important because if you've got multiple developers developing on the same application and you're both pushing into test and QA, one of you is going to end up overwriting the other one's changes. If it takes a long time to get through the environments, someone else will come along and start pushing their stuff into test, and then it'll be fine. There's no merge conflicts because you've not merged yet, and you're going to end up with more merge conflicts, and no one likes a merge conflict. Interestingly, someone told me that the collective term for a group of programmers is a merge conflict. Seems to work, yeah. If you need to sign off things, so if you're writing a new feature that's going to be visible to the environment, visible in the production environment to people, but it needs sign-off from a business person to say, yes, this is fine, I want this to go into production. You don't want to gate it behind, it's in QA, but we can't push it into production yet. For this kind of thing, you want to use feature toggles. It's outside the scope of 12-factor applications, but I like feature toggles a lot, but please make them short-lived, because otherwise you'll have a lot of problems. Yeah, I have an entire talk about people who've messed up with feature toggles. It's hilarious. So large TTLs, like time to lives, a bad thing. Shorter ones, better. Shorter ones, smaller branches are better. Make things smaller. Yes, right, nearly done. So the next part is logs. Now, treating logs as event streams, when I first read this, I didn't quite understand what the point was. I mean, what else is a log file if not a stream of events? I mean, it is, but the 12-factor application, we're not allowed to rely on the disk being there. So we can't write log files to disk. So where are we going to put them? How are we going to get them somewhere that we can manage? Especially if we've got a lot of containers running. How are we going to get all of our logs into one place? Because I don't want to have to try and find the container in the cluster of other containers and then attach some kind of console to it and then run cat on the log file and hope that it returns the right stuff and go through all that. We want to push them all to Elasticsearch or some other centralized logging system. Doesn't really matter at this point. But how do we actually get them there, especially if we're not allowed to touch disks, and we don't want developers to think about this? The answer is to use Filebeat and essentially Logstash. You don't have to worry about the specific implementations of this, but we use Filebeat, Logstash, Elasticsearch, and then eventually Cabanas stuffed on the front so we can do graphing and look at things easily. But we want to get our output from our application into Filebeat without touching the disk. And as the name Filebeat has the word file in it, doesn't seem like it would be a great fit. But it turns out it's got a feature to handle this. So in our startup, we've wiped out all of the logging that comes by default in the framework and replaced it with Serilog, and we've just got a single console output, which is going to write JSON on a single line. Now, if you've not come across Serilog before, it's structured logging. So rather than just being a rendered string of a log entry, it is a template and then key value pairs of all the values that go into it, which mean you can query on individual values. It means that this is the kind of thing you'll get on your output, but compressed onto one line, super readable. Now, this has got all the information for a request coming into our application. Now, if that's all coming onto one line, it's not very useful to the developers. We can solve that, though. What we need to do, primarily, is get this into Filebeat somehow. Now, Filebeat, this is the entire config you need to make this work. This basically says, read off the standard input, add an extra field called environment, which will read from the environment variables for a variable called environment, which will default to local if the environment variable called environment is not there. I need to get the word environment in there more times. I don't know how, but... And then we will output it and write all the stuff to our Logstash server, which is running somewhere else. Now, how to actually hook these two things up together, the output of our console and the input of our Filebeat thing, is very simple. This is the running of the application beforehand, and this is the running of it now. Just pipe the output. Linux pipes, the greatest invention ever. I mean, anyone can handle that. That's like a 15 character change in your Docker file, starting the application. Locally, you might want to use something else to render your application. Now, Siri Render is a project that I've written to do this, which I should probably open source because it's kind of useful. But essentially, this reads the log file off the command line and then reprocesses it and outputs it as if your application was outputting nice log messages. So it's quite useful for local development. But by doing this, the actual dealing of log files was just this. And that's what, 1, 2, 3, 4 lines. And you could get away with 2 lines, I suppose, if you made them really long. But developers now don't have to worry about running out of disk space because they've forgotten to add a retention policy to how often they write to log files. They don't have to worry about file permissions or what directory the log file should be written to because Filebeat needed somewhere to pick them from. We've removed so much little overhead from the process. So as long as I call log.write, log.info, whatever, it'll come out into our log files. So yeah, removing tiny bits of complexity. And it means our application is now just the business part of it, just the value it needs to provide. It doesn't have all of the overhead of write to the file, check the file exists, rotate the logs, delete the old ones. That doesn't need to be there. So you're not going to get random slowdowns in your application because it's suddenly trying to shift everything around on a disk because it's deleting a file. So you've made your application slightly more stable. The final piece of the 12-factor is the admin processes. Run admin or management tasks as one-off processes. And when I read this, I read it a few times like, what else would you do? I couldn't think of another way of doing anything. And then I thought, well, maybe they mean like when you had a monolithic deployment of something and on startup it would migrate the database to the new version and then work. But I can't remember the last time someone tried to do that with a container because you'd start up several copies and they'd all try to migrate the database, and I'm imagining that wouldn't go well. So what this is implying is that we should be having a separate application for things like migrating databases, doing administrative things, but it should be deployed with the main application. So going back to our repository, it would be another folder in there of just like tasks. So my Genius application, which is called 12 because I'm very imaginative, we have 12.tasks. Now this is our command line which does the things. We can inspect stuff stored by the service. We can migrate our database. We can do a GDPR thing because that's important these days. Like report on users or anonymize them. Anonymize the users, not anonymize the reports. And then we have a retention which just purges everything. Now the retention one could also be used as the background job. So you could just have a cron job executing that. That would be valid to do. But things like migrate the Postgres database. Where did that connection string come from? Well, console. And its username and password, well, that came from Vault, but on a slightly higher permission than the normal application has. Because the normal application doesn't need to be able to do schema migrations, it just needs to query and write data. But we're using the same configuration objects. So all of the common properties are in sync with the main application. You're not going to, right, here's my task application. You run it, and oh, the schema is not quite the same as the application expects, because they're deployed together. And here we have an example of me migrating the database. And we've got an optional parameter to force a particular version. This library for doing this, by the way, is called Oakton. If you've heard of Storyteller or Structure Map or Martin or Jasper, all written by Jeremy Miller, this is another one of his tools. And it abstracts the console away from you having to handle it. So we have an input object here, which is my migration input. It's got a description and a version number. And then we have a command handler for it, which has two usages, one with the version and one without. And then we have a single method which actually handles running the command. You probably actually have some values in there and return something useful, but I couldn't fit anything more on the slide. I like Oakton because it makes your the actual tasks application very testable, because I can pass in fake command inputs and test it and test that it actually works. So we can do test-driven development on the command line. I don't think there's anything more to say on that. And that was everything. That was the whole of our 12 factors. Now, we've got some links on there. The first link is not live yet, but it will be soon. Soon has a little asterisk after it. It will probably be about a week. The second one is this presentation. If you hit the letter S when you view the website, you'll get my speaker notes, which will probably not be very helpful because they're very short. And then we've got the official 12-factor documentation, all of the HashiCorp products, which I'm not paid to sell, but you should use them. And then the Microsoft guide on setting up Nginx and using it as a reverse proxy. So with that, I've got a few minutes to questions if anyone's got any. So thank you for attending. Oh, no questions? So yeah, if you've got any other questions, come and grab me or send me a message on Twitter or something.